All right, perfect. All right. Thank you all for coming out to our first speaker event of the quarter. Today, we're really excited to have Mr. Jayesh Lakumb. He's a product manager at Oracle, and he will be talking more about data science through a PM's point of view, which is something that I think a variety of perspectives in data science can really enhance your understanding of the field as well. So uh, get, I want to greet him pretty, what am I saying? I'm excited for him to be here. Um, I hope you guys are as well. Um, Take some time while he's talking. If you guys have questions, put them in the chat. I'll read them out to him as these go and continue as the speaker event goes on. So with that being said, I'm going to take a step back and I'm going to let Mr. Lakumb do all the talking. So thank you for being here, and we're really excited to have you here.
Yeah, great. Thanks for having me, Rahul. And the rest of the folks here, thanks for taking the time. Rahul actually first approached me to ask if I knew anybody at Oracle who can speak about data science. And so the funny part here is that I ended up nominating myself for this because I think Rahul may not have really understood my role at Oracle. In full disclosure, he's my nephew, but I haven't really talked to him about a lot about what I do. And but you know, when I got to thinking about it, it actually made me think a little bit about my career and the intersection of product management and data science. And so I'm going to share a few stories today, and hopefully that'll kind of spark some thinking about what is product management and how it really enables data science and how we kind of collaborate and makes drive solutions in the industry. So that's what I'm going to talk about today. And I've got a short slide deck here. Let me start with that.
You have the ability to screen share, right?
Yeah, yes, right. I think I do. All right. Okay, great. So really what I wanted to take some time first is talking a little bit about what is product management. But before I do that, just a quick intro about myself. I've basically been a product manager for about half of my career, and the other half was in development. So, before I moved over to the dark side, I used to write code. I've done a number of different types of solutions, mostly in robotics and automation, writing motion control code, and also in natural gas industry. So I've got a little bit of industry background, which helped me quite a bit. And then along the way at a company called OSI Soft, where I was really dealing with time series data and IoT, because before it really sort of became a thing, I kind of cut my teeth on product management and had a chance to make a transition in my career. After I left OSI, and OSI is really more of a horizontal platform play where it's a set of capabilities around how to really leverage time series data. You may have been using some of the time series data in some of your classes, and there's a lot of I would say a lot of insights that you can derive from time series. And so, this is mostly time series focused on industry data. And so some of the examples that you'll see and hear me talk about are related to that, because after later on in my career, I worked at GE, and in the power industry, power and water and renewables industry, along with a solar startup called Power Factors. And I'll share, a few examples of that. And currently I'm at Oracle Cloud, and we'll talk a little bit about, some of the solutions that can be built, leveraging these, SaaS and cloud, and really using industry knowledge in that. Okay, so what is product management all about? I guess first, maybe, I don't know if we could get a kind of a show of hands, or if people could maybe comment real quick in the chat about whether they have familiarity, either they have a product management background, have worked as a product manager, worked with product managers, taken any PM classes, that sort of thing. Okay, Dylan, great. Okay, I know Rahul has some experience there. So, I think that for most folks, product management is it's kind of a function that people are aware of, but may not realize what are all the various tasks that fit into that, right? And so this is one of the frameworks that I learned early on when I was just getting into product management. And there are 37 boxes here, and all of these boxes sort of fit under that umbrella. And I just wanted to kind of just sort of paint this picture of what are all the different tasks that a PM can perform. And I've worked on probably all of these throughout my career. Most of the ones here on the top left are kind of more on the strategic side. The ones in the middle are more from a technical product management. So, really building and developing new products. And then over here on the right-hand side, you're talking more about sort of product marketing and outbound enablement. So those are all the different tasks. I think most of the focus from a PM cross-section with data science is going to be in this middle area. But you'll see as we talk about, as I talk a little bit about some of my experiences, how that kind of relates and what some of these boxes, I would say how they can impact both the product side and the data science side. Okay, so with that, I'm gonna share a few stories. I've got about 4 or 5 slides. And I've got a couple maybe bonus stories that I can throw in depending on how much time we have. So the way I've structured this is basically talking about an individual solution that I've worked on. I'll tell a little bit about what that solution was about, and then kind of what are some of the things that that worked in terms of building that solution, what didn't work, and then maybe what I learned along the way, and hopefully that's something you guys can take away. So the first one I worked on was a product called Operations Optimization at GE Power, and it was really targeted to combined cycle power plants, customers who are trying to really squeeze more out of their power plant, right? And so the approach here was there's a number of different KPIs that say a plant manager wants to or uses to understand the performance of their power plant. And an asset manager who might be looking across multiple power plants to really understand how well their business overall is performing. And those KPIs are kind of shown here, right? So it probably, it probably doesn't make sense necessarily for somebody who is not let's say a gas turbine engineer, but these are really KPIs that there's a lot of analytics behind those, which helped the end user, be it the plant manager or the operator, understand how well a single turbine or the entire plant is performing, right? And so they use these KPIs, and of course, the underlying data behind that to really drive their operating profile for an individual power plant. And so it's really important to understand what those KPIs are telling you at any specific point in time. What's interesting is that in general, a power plant, the way it's run is there's a specific set point that you're trying to meet. It might be exact, the sort of the maximum capacity of the plant, of course, if you're trying to maximize your overall revenue, but there might be cases where you're not able to achieve that overall, that nameplate capacity for the plant, right? And that could be a function of the capability of the plant at the time. Maybe there's some, certain maintenance going on at certain parts of the plant, or the fact that, if you look at the operation of a gas turbine, it actually degrades over time. And you have to go in, you periodically have to go in and do things like a water wash, for example. So it's important to understand kind of how these assets operate, to also understand what that data means that it's, reporting. And so a lot of the examples, by the way, I'm going to give are kind of IT and OT, meaning the operational technology as well. And so I'm just trying to give you guys a little bit of background there. But for this particular solution, one of the things that we did was we tried to change the behavior of how a customer might operate their assets, thinking more about it as, really, how do I not just generate power, but how do I derive a certain outcome, right? And the outcomes in this case is about specifically, these particular KPIs that you see at the bottom here. And so sometimes what's very interesting is selling software, right? Of course, software is sold as a subscription or a license, but sometimes you can sell outcomes. And specifically from a data science perspective, if you have the ability to provide certain insights like that, you can actually sort of change the behavior of the end user and drive a certain action as well, right? And so the particular outcomes that we were looking for, as an example, was, we'll help you get, let's say 3, 4, 5% more megawatt output from your power plant. And so you can monetize that, right? And so selling a different commercial model is a great strategy from a data science and solution perspective. The other thing that worked well here was, building a digital twin model of the entire power plant. And then really one of the key things is, if you look at for a power plant and for a utility customer, they're going to have a number of different sort of competing priorities, right? So within a power plant, well, for the asset manager, let's say, they're really focused on the pro forma of the plant, meaning how much money am I generating from that power plant? They're entirely incentivized on profitability, right? The plant manager, though, might be much more, concerned about ensuring that their plant is available and running and operating. And then the maintenance manager might be just concerned about, safety and making sure that they're meeting their maintenance schedule. So those things may not always line up. And that's what's important sometimes about solutions like this, where, you have multiple, let's say, stakeholders who may be looking at the data that's provided here. It's important to kind of align them. And so that was one of the reasons that this solution was built, to provide that level of transparency to all of those various end users. So what didn't work so well, perhaps, in this solution was we also took a very broad scope here in terms of trying to build a large library of analytics. It actually takes hundreds of analytics to sort of distill down into these various KPIs in order to calculate all of that. And so we actually tried to build this solution in such a way that, we would introduce individual KPIs and sort of kind of light that up within the solution. But really, because the scope and the I guess the initial vision of the product and the customer expectations were quite high. That was one of the challenges of really just managing the end user's expectations on that. The other thing that I learned when I took on, I actually came in and took on this particular product, but there was some history behind it. It turns out there was GE being a large company, there was a competing solution within GE that was already, that a few customers had already, used. So I wasn't aware of that, didn't find out until later. But sometimes it's important to understand maybe the history that customers may already have a certain, perspective or bias about, about your solution. And so that kind of, in some ways it made some customers somewhat hesitant to try a new solution because they'd already been burnt in some cases. But what I learned really was, when you're building solutions that really, that involve analytics, it's important to find the right co-innovation customers, right? Working closely with them, you'll learn so much in terms of what their real needs are, where their, kind of what their challenges are. What are they trying to do? How do they solve those challenges today? Because oftentimes, that's really your competition, understanding kind of what is their current process and getting them, to change or move from that current state to, using your analytics and your solution. So, finding a co-innovation partner who, you establish a trust and rapport, that's super critical in terms of getting to a kind of a partnership that, they trust the solution, they're willing to share the data, they're willing to give you feedback that's, helping you drive to a better product, right? And so that's something that takes time, by the way. And this is where the cross section here of the product manager and the data scientist working together really to enable that end customer is very critical. And then, I think this probably goes without saying, but any analytics solution is really only as good as the data behind it, right? The data that's used to develop a model, for example, and also the data then that's used on an ongoing basis as the solution is running. And sometimes, that's not so easy in certain industries, specifically in a hardware industry, a hardware focused industry like like power. Customers may feel like, hey, that data is maybe proprietary, or at least it might be sensitive. And so, overcoming that hurdle where a customer is willing to share the data with you, is something that you kind of have to get past that point. Again, that's a function of working together with your product manager, with the sales team, and hopefully, that'll get you the right data so that you can get derive the right insights from that. But the other thing is, and one of the reasons why I left GE after 5 years is that really hardware companies, they just don't get or value software, right? And so as much as these analytics were, let's say, valuable and insightful in terms of the types of, in terms of the information that could be really gleaned from that, which was very different, let's say, than any other vendor had in the market at the time. The end customer just felt that they were buying a gas turbine, and so the software should come for free, as the way they kind of looked at it. And frankly, within GE, they didn't really understand how to value, these analytics and the capabilities that we were providing. So, it's just something to be aware of. The commercial side of things, of how you turn analytics into a product that you can sell, is just as important as how you build and what is it that you're building. Okay, I can pause here if there's any questions, Rahul, or I can keep going to the next story.
Yeah, we had one question in the chat from Jeremy. He's asking, so customers in this case is each different factory?
Yeah. An end customer would be a utility. And so they might own one or more power plants in this particular case. Yeah.
I don't think there are any more questions.
Okay, great.
There are, please put them in the chat. I'll be pulling them, and then for the next section, I will be able to moderate.
All right, so I'm also, the way I've kind of structured this, I'm going to share a couple of some of the solutions that I worked on, which I would say are they had promise, but they were definitely failures. And I think I learned just as much, if not more, from some of my failures during my career or early on in my career that I then applied later on and got some great success with it later. So you'll see those stories as well. So here's another one that had good promise. So we had a customer, Exelon, who's one of the largest utilities in the country. They came to us and said, look, we've got a wind energy forecast, and we use the data from our wind farms to model what the forecast will be for the next 5 minutes, let's say. And then 5 minutes is because that's the interval where they dispatch the power for that farm. In other words, they tell the independent system operator how much power they're going to provide to the grid from each of the wind farms. And so, they have to forecast that in order to accurately dispatch the power. Well, their existing model was somewhat basic and had a lag due to that. So a lot of the I'll say the simplicity of the model was using historical data, but basically saying, well, whatever the data was from the last 5 minutes, we'll kind of use that going forward until we see a significant enough change. Now, what they were looking for is to reduce any under forecasting, because the wind will change dramatically, especially we're talking about wind farms in the Midwest. The wind changes pretty dramatically where it ramps up and ramps down like this. Now, when that happens, if you forecasted a number if this is the gray line here of what the actual wind production, that wind farm production is in terms of megawatts. And so if you simply, if you under forecast, then you're leaving a lot of power on the table, right? Because you're not dispatching that much power. And if you over forecast, then you're actually paying a penalty, because if you don't deliver the amount of power that you said, you have to buy that power on the spot market and sell it back to the system, to the market. So what we learned from building a new model for this, a couple of things. One is that it's actually very possible to build a better time series forecast model that achieves a specific objective function. In this particular case, we tuned our energy forecast to reduce the under forecasting. So the intent was, when the wind really ramps up, we wanted to make sure, because it was actually more costly to sort of under to under forecast than it was to over forecast, right? That had to do with something with a little bit with the market dynamics in the Midwest ISO. So we worked with the customer to get their particular historical data for each of those wind farms, and then tuned a model specifically for each farm. So, it worked pretty well in this case. Now, what didn't work is sometimes, you can build a great model, but if it takes too long to put that into production, we showed them, by the way, we showed them a historical, once we had trained a model, we showed them what it would look like if we, based on our particular model, if that was in place during that, let's say we had 2 years of history, we took 1 year as the training data set, and then 1 year to, kind of demonstrate this was the, here's how our model would perform during that 1 year time period. Of course, this was all historical 2-year data. And, they could see that there was, the model actually performed better than their in-house energy forecast. That was great, but that was all sort of, in theory, meaning it was only on our, in our Jupyter notebook, not really something that they could put into production yet. So going from, here's a model that we've built to here's a model that we can deploy and run on real live data can take a long time. And so, that was one of the challenges that we faced. And also, by the way, we were trying to tackle building multiple different forecasts. So the example I gave you was for a real-time forecast. They also wanted a day-ahead wind forecast and a 7-day energy forecast, right? So basically trying to build that required different data sets, different weather forecasts, for example. Obviously, the accuracy of a day-ahead or 7-day wasn't necessarily as high as, their requirements weren't to make it as accurate as the real-time, but we had to build multiple models. And so sometimes, tackling multiple use cases at the same time can kind of spread yourself thin in terms of, addressing the different customer needs. So what I learned along the way, it's very important to leverage a platform. And in our particular case, we were building on the in-house GE Predix platform. Unfortunately, that platform was actually not very, it was actually being built at the same time that we were building our solution. And so that didn't work out too well because we ended up having to build a lot of the services that should have actually been part of the underlying platform. We had to kind of build those ourselves. So it took this particular solution. If you think about it today, you might say, well, this is fairly straightforward, fairly trivial. I can probably build an LSTM model or a profit model, or one of the well-known, let's say, time series forecast models that I can take a REMA model and just use that very quickly. And that's probably built into many different cloud services that you could leverage. And that's true. It didn't exist at the time that we were building this. And so, starting with the platform and ensuring you have the right services available it's a huge accelerator. The other thing is that change management is just as important. So even though we built this model, and once we did deploy it, getting the operators to use it and trust it, and then dispatch power based on what our model told them versus the existing in-house model that they had, that's a matter of like sort of building trust and getting them to I would say have enough faith in the solution that we're providing relative to what they already had. That change management is important for sort of, really working together with the end user on on the analytics and why the analytics are telling them, giving them a different, let's say, a different recommendation than what their existing solution told them. And then, we actually worked with a consultant to do that change management. And it turns out that consultant they took a look at what we provided, and they said, well, we can develop a very similar model. And so sometimes, unfortunately, it just worked out in this case that this consultant built a solution that it turns out, worked just as well, or was good enough, let's say, for the customer's needs. And because the consultant actually was working closely with the end users, he established the trust and got them to use his own solution. And so here's something that we had sold them for, over $1 million for this particular forecasting model, because we were deploying it at 42 different wind farms, and we ended up getting displaced. So that was an unfortunate end result on all that. Okay. All right. So the next story I have, so hopefully, so now we're going to talk a few stories about that have a happier ending, let's say. Also in the wind space, there's a product that I worked on called Power Up. And Power Up was basically, if you look on the right here, it's that's essentially the power curve for a wind turbine. Okay. And the power curve for a wind turbine is simply the power versus wind speed. This is the ramp up for a turbine, and then it hits its rated capacity, and then there's what's not shown here is a ramp down as well. Now, the goal for Power Up is to use a set of analytics and hardware and software. Could be a combination of hardware and software to shift the power curve up and to the left. Now, what that means is that there's more power being produced at lower wind speeds, or even at the essentially the max power curve for each turbine. Now, if you do that across, even if it's only a few percent on each turbine, and you do that across an entire wind farm, that is literally worth millions of dollars. So there's a number of different sort of knobs that you can tune on a wind turbine, but how you tune those really affects how well that turbine can perform. So one of the first things that we did in terms of this particular solution, there were a lot of different sort of engineering. There are literally about 1,000 parameters on an individual wind turbine controller. And one of the things that was being done was engineers were providing recommendations to I'm talking about wind turbine engineers, providing recommendations to the utility customer on how to set those operating parameters for the turbine, right? So that might be things like, the pitch angle, for example, for each of the blades. Now there are default settings for those, and those could be tuned. If you tune those properly, though, you can, essentially capture more of the wind. We were selling those types of upgrades in terms of, the tuning parameters for that. We were selling those as kind of onesie twosie. We'll do this for a specific wind farm, and that's, we'll give you the pitch angle, and then we were selling the yaw parameters as another set of upgrades. What we did was we said, well, look, let's package all of this together. So the first thing was sell it as a single bundled solution. And secondly, it was more of a commercial innovation than it was a technical innovation. We simply said, look, we'll sell it as an outcome, right? So we will actually guarantee that we'll give you X% more power for your wind farm. Now, of course, customers are very interested because they're able to, with the same assets that they had before, get more power output, and that was huge. What didn't work was when we had to build really the back end, which was collecting data from all of these wind turbines all around the world, right? Literally 30,000 plus wind turbines. If you didn't have the right data and the metadata architecture to really support that, these turbines produce time series data. It's not a lot. It's like let's say one power output for each turbine. If you were to collect it in real time, it would be available, let's say at 1 second, 1 hertz, but we were only collecting aggregate power out for each turbine at once every 10 minutes. But if you don't have, now you're talking about 30,000 turbines, if you don't have a good time series data platform behind that and the ability to mine that information, it's a challenging problem to solve. So the other thing I learned is when we were thinking about how we were selling this and building a business behind really Power Up and being a digital company as GE, understanding the big picture is important, right? So from a product perspective, it was, what we really wanted to do was sell the wind turbine as a service, right? So we were really rethinking how we're selling the asset itself. And that had an implication, of course, on how we sell software and the analytics behind that. So understanding the commercial model is important for how you're building your the solutions that you're providing. So what that meant was, as an example, we had to know that if we were selling this outcome as a service, then meaning 5% more annual energy production for the wind farm, we had to be also able to monitor that, and we had to forecast, based on what we expect the let's say the weather forecast to be. We had to basically anticipate what the output for the farm would be, and provide that information to the customer, and then show, hey, look, we validated that we actually were able to achieve more than what you anticipated or what you expected before Power Up was installed. So, the other way we did this was we actually set up a single wind turbine in the farm and said, hey, that's our control, meaning we're not going to put the analytics, we're not going to run those at that time. So that's going to be our default, and we'll compare all the rest of the turbines versus the control. So it's not an easy problem to solve because the wind at each point on a wind farm is not going to be the same. But that's, proving that out is actually another difficult problem to solve. So even though you might have good analytics, in this particular case, the wind is a variable resource. And so it doesn't always, sort of prove out. Sometimes we got into contract negotiations and sort of, I would say some very contentious discussions with customers about whether the solution actually delivered what it promised. But for the most part, many customers were very happy with the fact that, they were able to see that 5% is a meaningful difference. Even if it was maybe only 4%, in many cases we were under promising and over delivering, and so they were quite happy with the results of this solution. It's actually still running today on over 10,000 wind turbines. Well, that was about when I left GE a few years back. We had over 10,000 turbines running this, so it's probably much more now. Okay. The last story I have is the company I worked at prior to joining Oracle is a startup called Power Factors. Power Factors is focused on same renewable space, and one of the one of the key products is well, the platform is called Drive. And when we added analytics, solar analytics specifically to Drive, the goal there was, again, also to identify, how do we improve the output for a solar farm, but mostly also, but really because there's not the same sort of tuning parameters that you have on a solar farm as you do on wind, but mostly to identify underperforming assets so that customers can then go in and try to understand, what's happening, what are the cause of, let's say, any losses on an individual wind farm. Now here, what we started out with is, this was really, a very strong data scientist who had a lot of experience in the solar space. He had worked at Panasonic, and, really in terms of building and working on, the solar modules themselves. He understood kind of what the data was coming off of the solar modules, the panels, what that data was able to tell him. And you can kind of see down here some of the graphs, inverter efficiency, and it's measuring, AC versus the DC side. And you can kind of see, or he could kind of see visually what, how well a solar farm or an individual, let's say a string or like at the combiner level, the solar farm is kind of a hierarchical array of assets, but understanding and looking at the operating data off of the solar farm, he could immediately see what was happening. And there are a number of different, let's say, events that could happen on a solar farm where the data set, this what you're looking at here is actually a very good data set, but oftentimes you'll see, for example, it flatlines over here, and that's a function of clipping. And so if your inverter is undersized relative to your solar farm, if you hit the maximum output, the inverter is no longer able to deliver more AC power than what it's rated for, and that causes clipping. And so, it's things like that to understand how the assets performed is actually requires that industry, background. And so we were able to build new analytics, by the way, which took into consideration all of these different operating curves. And we used machine learning to teach a model what does a good operating curve look like for a solar farm, and then also what are some of the, let's say, if you were to look at certain conditions. So, for example, if there's shading that happens on a solar farm, meaning there's let's say there's a building or trees, and shading occurs at a certain time of day, maybe cloud cover, what does that look like on a solar farm? Being able to model that and understand that particular, or snow, let's say on a solar array is obviously going to cause a big drop in the energy output. But seeing that visually is one thing, but then understanding, identifying that simply by using analytics and identifying it at scale is a huge challenge, because of the amount of data that you might have on a 100 megawatt solar farm. There are a lot of data points that are coming off of that, literally hundreds of thousands of data points that are coming off of a 100 megawatt farm. Fortunately, we had access to a large customer data set. In this particular case, we worked with the customer, Terraform Power. Because we were part of this DOE Sunshot grant, they were our co-innovation customer. We had access to all of their historical data because they had already onboarded their assets onto our platform. And in fact, commercially, Power Factors actually had an agreement within to actually use, as long as we anonymize the customer data, to use it to build models. And so that gave us a huge advantage relative to our competitors in being able to leverage that data set. And then we also had the right, really the right architecture, because it was built by a team that understood how to deal with time series data, and then how to I would say build an analytics infrastructure around that time series data. Now, one of the things that didn't work so well, perhaps, and you guys probably experience this on a regular basis, is that data scientists maybe one of the, or in data science itself, I will say, being a data engineer, I guess having to clean data and manage data is just unfortunately part of the job sometimes. If you can, I guess, if you're working at a company where they do have data engineers, that's always I guess a great resource to have available. But sometimes, in our case, we were a startup and we just didn't have the resources to do that. And so unfortunately, it fell back to the data scientists to really clean and manage the data. But anyway, what I learned is one of the things along the way was we initially tried the models that we had developed and tried those on another customer's data set, and really quickly came to the conclusion that there were a lot of data quality issues with that customer's data set. So even though we had built models that worked, at least for one customer, we were getting fairly poor quality data across the board for the rest of our customers. So we needed to pivot and change to solving that problem first. The way we did that was, we had a number of data cleansing routines. Well, first of all, we checked the data, the metadata that we had around those other customers. So in some cases, we had incorrect information on the types of, let's say, the types of manufacturer of the inverter or the solar module. So we didn't really know exactly what its expected, power output. And so, some of our models weren't applying properly in terms of these different operating curves. So having the right metadata. Also, as a solar farm is built, you might have certain drawings on how the farm should have been built, but the as is might be very different. And so we needed to have some ground truth, or at least confirm with customers what really happens, what really happened out there in the field, in terms of sometimes they change the orientation of the arrays. Sometimes the arrays, there's trackers that are installed, but maybe then there should be installed, but they're not installed. The trackers actually move the array as the sun tilts towards us, to tilt the arrays toward the sun. And so our models were expecting that it would operate a certain way, but then of course how things are actually in the field is sometimes a different story. So working through those data quality issues, we were able to also highlight to customers, these are the things that we don't know. If you can tell us, then we can improve the data quality, and then we can give you better analytics results. And so this is actually one of the key things in terms of a partnership with a customer is basically highlighting or being transparent about where are some of the data issues, help us fix those. And if you can help us fix those, we can give you, better quality results. Yeah. So anyway, that was, pivoting to solving that problem was a big, sort of stepping stone to allow us to then build and provide good quality analytics. The other thing that helped us a lot was having a really intuitive user experience. Now, there's a lot of data that you see in these screens on the right, but you think about how we tried to simplify and summarize. There's a just to kind of show it here. There's a set of wind farms. This is a waterfall chart that simply shows the different types of losses that you might see on an individual. I don't know if this is an individual farm or maybe yeah, this is an individual farm here. And then, what are the worst performing plants that our analytics, which we're running on a, let's say, daily or weekly basis, would highlight what those are. The user could simply click on an individual plant, and then it would, help them drill down to, let's say, a specific inverter at that plant, and give them the, the next level, transparency. It's important to kind of summarize, start with those KPIs that the end user is really thinking about, show them let's say the kind of the confidence level that we had. There was another chart in here that in the solution that kind of showed them, here's where we think that, what's, let's say, a range of kind of what our understanding is of how much these losses really are. And giving enough of that transparency to the end user so they could see kind of and kind of earn their trust, right? So an intuitive user experience is critical, especially when you have a large amount of data. And then the other thing I learned, and I call it the system sandwich, right? You've heard these terms before: system of record, system of intelligence. There's a number of different sort of layers in a solution. The system of record is your underlying, well, I would say the system of automation, or is your kind of your underlying infrastructure. The system of record is think about it as your database. There's a system of intelligence, which is your analytics. There's a system of integration, which is how you connect to either data coming in or out. And then there's a system of engagement that sits, which was kind of the visualization of that of your solution. So system of intelligence is really just one piece of that, right? So one layer of that, you need to kind of think about these analytics in the context of all of the various layers and how it's all working together. And of course, this is important in terms of how you build your software architecture around your solution. But that system sandwich is kind of a good mental model in terms of ensuring that you're sort of building your analytics around a full, let's say, the full vertical and horizontal platform to enable those analytics to really work well. Maybe said another way, delivering a full solution to the end customer. Okay, so I've just got a few minutes left. Let me give kind of some key takeaways that I've learned, throughout my career. Kind of the things on the left are maybe a little bit more of a commercial / customer, and things on the right are more on the technical side, if you will. So, start by defining the value, right? If you're building a new solution, if you're building new analytics that will provide some type of outcome, understand what the value is and align that value to your, target personas. Those could be buyer personas or user personas, but really important to know what is the true value of what you're providing. And some of those examples that I showed you, there were KPIs, and those KPIs, described that value. And then communicate the value props, right? There's a simple, sort of mnemonic here. It's just developers like data, finance likes figures, and sales like stories. That's how you communicate to those different stakeholders, right? And so, just something to keep in mind in terms of your, communicating the benefits of the analytics that you're building to different audiences. And then, working with the right partner. finding a good co-innovation customer, becoming a trusted advisor for them is, I mean, it's just, that's, there's no substitute really. Finding, I would say, somebody who's willing to try, and test out and give you good feedback. That's, then you can take that, build that into your product, and then, leverage that for your next customer. And then really understanding your end user persona. Make sure that the solution that you're building fits how they think about either, what is their business and how they want to either operate or use the solution to help drive their business and their processes. And then on the right side here, one thing I learned is that whoever owns the data really wins. So make sure that whatever you're working on, you really understand that source of the data. And frankly, hopefully it's a place that, you have real good access to that data on an ongoing basis, right? Going forward sort of thing. And in our particular case at Power Factors, for example, we had a large historical data set because we were already in essence monitoring a lot of these solar farms, and now we were building analytics on top of the data set that we already had, and we had access to be able to do so because of our commercial agreements. So that was a that just enabled us to kind of build really good quality products. And then establishing the trust, as I mentioned, in terms of how the solution worked. And then really software, by the way, is a team sport, right? So, it requires a mix of different disciplines, and it requires different expertise. You kind of have to have people who know, I would say the vertical, meaning your particular industry, and also the horizontal, in terms of like knowing how to build, a good platform, for example. And then, agile working in an agile, environment. Sometimes that's challenging for data scientists, but if you can find a way to kind of work together with developers, in an agile fashion, I think that, it sort of helps in terms of keeping that cadence going for, developing and releasing new products. Okay, last thing is, I just wanted to share a few resources for the folks here. Oracle Cloud, we've actually, in case folks are very much familiar with AWS and Azure and GCP. Oracle has we're a general purpose cloud, just like the sort of the big CSPs, cloud service providers. You're going to find that there's a number of very analogous analytics services that we offer. And so if you go to these links, there's some live labs you could go out and try yourself to see what types of services that we have. There's a free tier, so you can actually test out some of our analytics capabilities. You can even get certified. Some of the training is free to be able to use those OCI services, and then that's something that could probably help kind of jumpstart your career in terms of knowing how to use OCI and the data science capabilities. And then there's something called Oracle Academy as well. So I'll let you guys take a look at those links offline, and then I guess if there's any questions.
if you guys have any questions, feel free to put them in the chat. It'll be, see, 7:05, so we're a bit over time. So any last minute kind of lingering questions? I will take a screenshot of this and I'll post these links in our Discord server for you guys to be able to access later. Let me do that now. So you guys will be able to access some of these later and can use some of these at your disposal if you feel so inclined. But for now, I don't think there are any other questions as far as any that I may have. Most of them were answered throughout the duration of your talk. So
Okay.
if there are no other questions, then thank you so much for doing this. You are our first speaker of the quarter. I learned a lot. I hope everyone else here did as well. Um, and yeah, thank you. And let's remain in touch.
Sounds good. Thanks a
Awesome.
lot, everyone.
All right,
Bye-bye.
bye guys, and yeah, we'll see you guys later. Awesome. I will stop the recording.